Hi, hello everyone. I'm Xinxin from the West Coast Wave Initiative Research Group, which is at the University of Victoria campus on Vancouver Island. The topic of my talk today is using ArcGIS to identify strategically important wave energy sets. The average electricity demand for Vancouver Island is around 9,000 gigawatts hour each year. Half of the demand is generated by this island itself. The remainder is being generated on the lower mainland of British Columbia. With the increasing electricity demand, the expensive transmission upgrades between Vancouver Island and the lower mainland will be required by 2023. If we want to avoid this costly transmission upgrades, we must find new power generation capacity on it. The Vancouver Island is in northeastern Pacific Ocean, just off the coast of Canada, where it possesses one of the most energetic wave climates in the world, thus attracting people's attention to wave energy. In addition, wave energy provides highest power density, relatively continuous and predictable power in contrast to other formats of variable renewable energies. The peak of wave energy in British Columbia is in the winter, which can provide a natural source for the seasonal electricity demand peak. The West Coast Wave Initiative is a research group that seeks to determine the future role of wave energy in Canada's portfolio of renewable energy technologies. The previous research in my group provides us a better understanding of the wave condition in the ocean, but now we would like to take more elements into consideration when we decide the location for wave energy. That is because the coastal area have been utilized for many activities for centuries. The deployment of wave farm will impose a restriction on other marine activities, increasing the risk of conflicts with other marine space users. It is a challenge for us to determine the deployment location for wave site with minimum conflict with pre-existing uses. Luckily, GIS is the tool to help us to solve this type of problem. All factors that in our mind influence the choice of wave farm can be represented by a single layer in ArcGIS. All factors or layers in this evaluation can be divided into two categories: exclusion factors and competing factors. Exclusion factors talks about area are not suitable for wave energy set at all and should be removed from the areas of interest. There are three groups of exclusion factors. First, area already be utilized, such as marina and ferry routes. Second, government park and protected area, where they host the sensitive marine ecosystem and have high conservation value. And lastly, improbable area for device deployment due to operation limits, such as ocean depth and seafloor composition. Competing factors talk about the environmental and economic factors that influence our choice of wave farm location. Each competing factor will be assigned a weight according to how strong that influence is. All competing factors we use here can be grouped into 5 major criteria: the wave power quality, installation costs, market size, marine conservation, and existing human use. Now let's look at our wave power quality criteria first. The top panel of the graphic on the right side tells the magnitude and the consistency of rough wave power. However, each type of wave energy converter performs optimally in a unique wave condition. All converters are sensitive to wave frequency, whereas some converters are more sensitive to wave direction. Because of this, frequency and direction filter can be applied to determine where a specific device performs best. Therefore, the factor composing this criterion can be chosen or weighted differently to meet those requirements. Here, I will use the rough wave power quality for this analysis. Now let's look at other major criteria, such as the installation cost, which is the cost distance to the transmission grid. The market size, which is determined by the size of the closest substation on the transmission grid. Existing human use, which is composed by the annual landing value of the commercial fisheries and the marine traffic density. And finally, the marine conservation, which is represented by the area have high conservation value. Each criterion layer needs to be normalized to the same scale. Here we will use from 0 to 100. The higher score, the greater potential for that location to be a wave farm. And each normalized layer is then assigned a weight according to their importance. A suitability index at each site is generated by summing up all those weighted layers together. How we weighted these layers will influence the resulting suitability index significantly. Consequently, a scenario study is developed to investigate how different weighting schemes will influence the resulting potential wave farm location. This study can be done by 3 steps. First, set up the weighting schemes for each scenario that according to each agency's interest. Second, define hotspot within each scenario that stands for each. Define hotspot within each scenario that stands for the ideal wave sites selected by that agency. And finally, we will overlay all those hotspots from each individual scenario and to find the strategically important wave energy site. When we set up the scenarios, the criteria could be chosen and ranked differently to match each agency's distinct interest. As we can see from the figure, environmentalists care more about marine conservation, whereas commercial investors are mainly interested in profit and cost. The national lab, government, and the equalitarian will take all criteria into consideration. These steps will select the percentile of the suitability index to define the hotspot. We can begin with the top 10 percentile, but it may happen no intersection occurs after we overlay the hotspot together. In this case, we can let each agency lower their requirement, in other words, lower their percentile to redefine the hotspot to make sure some intersection will happen when we overlay them together. Here's a couple of the examples of the scenarios. And finally, we will take each hotspot from each scenario and overlay them together to find a strategically important area that can satisfy multiple agencies' interests. Ideally, we would like to find the intersection like the dark red in that map that can make everyone happy. Yeah. The original study area from in our group is around the lower part of the island, with it around Tofino. You may hear that city if you are a big fan of surfing in cold water. But now, after we applied this analysis, we find on the top of the island they have some place. They have really good wave resources, close to market, less existing human uses. Okay, conclusion. For the first time in British Columbia, we condensed a very large and comprehensive wave data set into a format that can fit into ArcGIS. Second, rather than tell people where you should build wave farm, I think this study enables people to negotiate the strategically important wave set that can strike a good compromise between competing priorities. That's all of my presentation. Thank you guys for listening.